Hello guys, today is a new video lecture about name reactions in organic chemistry. In this video lecture I will be talking about aldol condensation. Basically it's not a name reaction like behind a scientist or something, but it's very common and very famous reaction in organic chemistry, aldol condensation. So why this is called aldol? Because it's when its reaction is formed, it gives you a product that is aldol, means it contains ald, that is aldehyde part, and ol means OH, alcoholic part. That's why it's called aldol. Again I'm repeating, ald because of aldehyde and ol because of alcohol. Okay, so this is the definition of this reaction, like carbon-carbon bond formation via enolate addition and loss of water to form an alpha beta unsaturated carbonyl compounds. The reaction can be stopped at aldol point, but then later on the OH group is dehydrated and the double bond is formed. As you can see in this reaction, this is the reaction of aldol condensation. Why we call it aldol condensation? Because as a result of condensation, water molecule is lost, and this can be a base catalyzed reaction or acid catalyzed reaction. I mean, it can go with either of these two, either acid or base, doesn't matter, it will give you the same product. So the reactants for this reaction should be aldehyde and ketone. This is aldehyde and this one is ketone, or it could be both ketones or it could be both aldehydes, it doesn't matter. So one carbon serves as an electrophilic center and another carbonyl's alpha carbon serves as an nucleophilic center. Now if you look into this ketone molecule, the carbon next to this carbonyl is called alpha carbon, and the hydrogens attached on this alpha carbon are called alpha hydrogens. So these are alpha hydrogens. So what the base does, base deprotonates one of the alpha hydrogen and makes a nucleophile and attacks on this carbon to give you the aldol condensation product. So this is a product which we call alpha beta unsaturated carbonyl compound. So this is alpha, this one is beta, that's why we call alpha beta unsaturated because of this double bond, and here is a carbonyl group, that's why we call it alpha beta unsaturated carbonyl compound. Before we move into the and also this is a CC bond formation reaction, so there's a carbon-carbon bond formation. If you are doing retrosynthesis, you can cut this reaction from this position and disconnect it and make one part aldehyde and another part ketone. Okay, this was the additional tip regarding retrosynthesis. Before we further discuss the mechanism of this reaction, let's have a quick look on the literature. I'm just highlighting the three main journals or recent journals in which this reaction has been published, but this is a very old reaction. I'm not putting all of those research papers where this reaction has been published. I'm just giving you a hint or just a quick revision or a couple of examples of literature. Here this reaction was published in bioorganic medicinal chemistry in 2004, in advanced synthesis catalysis or tetraid, and this is a year. If you don't know, this is a volume number, this is a page number of a journal, just in case if you don't know. I'm just telling you. Okay, then let's have a look on the mechanism of this reaction. Let's first discuss the acid catalyzed reaction mechanism. So this starts from the from this protonation of this oxygen in a catalytic mirror makes an enolate. So this is ene, this is oxygen, this is enolate. Now this carbon acts as a nucleophile because this oxygen's electrons comes back, makes a carbon oxygen double bond, and this double bond of carbon-carbon attacks on the carbonyl carbon of this aldehyde, and this bond shifts or breaks in the favor of this oxygen, and you get an carbonyl and OH group. This is called aldol. Alright, now what happens, the next step is just elimination or dehydration of a OH group or water molecule. So this OH picks proton from the medium, it becomes water, and in the next step this water molecule leaves and gives you the alpha beta unsaturated carbonyl compound. Easy mechanism. I hope you understood this mechanism. Let's discuss the base catalyzed mechanism. What does the base do is picks proton from this position and this double bond goes right here and this moves top to the negative charge. In the next step, this negative charge reverts back, makes a carbon double bond oxygen bond, and this again similar to acid catalyzed reaction. This double bond acts in a nucleophilic manner, attacks on the aldehyde, carbon of aldehyde, and a methanol in a methoxide base. So you get aldol product again in the same manner like in the acid catalyzed reaction. You get the same aldol product in the base catalyzed, and then this base picks this proton. Okay, this arrow shouldn't be here. Okay, then this base picks this proton, and this bond goes there, and the oxygen in the bond between carbon and double bond oxygen breaks, and oxygen gets the negative charge, and this methoxide takes proton and becomes methanol. Now this next step, in the last step, this OH group acts as a leaving group. This oxygen reverts back, and this bond shifts there, and this OH leaves, and it gives you this alpha beta unsaturated carbonyl compound. Depending upon the situation, depending upon the reagents given to you in your questions or in the exam, you can select which mechanism you want to go. Again, I am giving you the quick, less than a minute overview of this reaction. This is aldol condensation reaction, very famous conventional traditional organic chemistry reaction in which you get aldol products if you are not dehydrating, if you are not using the further conditions, and then alpha beta unsaturated carbonyl compound is the main product, and this reaction can undergo either acid catalyzed or base catalyzed reaction. And this was the mechanism. You first get the aldol product, and then you dehydrate the OH group, alcohol group, and you get the double bond. Similarly, in the base, you also remove this OH group, and you get the aldol condensation product. I hope you like this video. Please subscribe my channel, and see you in the next video again. Bye.